Hey students, this is lesson 432. In this lesson, we're going to learn how to simplify radical expressions. In order to do that, we need to look at what seems to be happening with radicals, like what can you do, what can't you do to simplify it. So I'm just going to work you through one of those problems here. In this one, we're trying to see if the square root of x plus y is equal to the square root of x plus the square root of y. And so to do that, we need a table here, and we're just going to test some examples and see what happens. So, so in this problem right here, we're going to do the square root of 0 plus the square root of 0. And if you think about that, that's 0 plus 0, which is 0. And down here, instead of doing the square root separately, we're just going to add 0 plus 0 first, and which is 0, right? And then find the square root, and that's 0. And what I'm trying to see is, are these two the same? And in this case, they were the same. So let's try another one. What if we do 4s? So the square root of 4 plus the square root of 4 separately, is that the same as this, if we add 4 plus 4 first and then do the square root? All right, so this one, that's 2 plus 2 equals 4. Down here we have the square root of 8. And some of you are thinking, oh yeah, that's 4 too. But no, the square root of 8, and if we use our calculator to figure that out, you'll see that the square root of 8 is not equal to 4. It's actually 2.8. So I'm going to go ahead and fill that in. And actually, if you wanted to know if this is true, we already know it's not true, because one example that doesn't work is all you need. And that's called a counter example. So this is a counter example to this idea. So I'm going to stop there and just say that the square root of x plus y will not equal the square root of x plus the square root of y. And you may remember that in class I said square roots are like powers, that that a number to the 1/2 power is the same as the square root of numbers. And remember, with powers also, like if I did x squared plus y squared, that is not the same as this. So you can't distribute the two like that. Wouldn't work. So anyway, all right. So we're going to use, we'll test the other ones in class and see if they work. But we're going to do a couple examples here of how you simplify radicals. All right, so I'm on the top of page 9 right now, and I'm going to show you a couple examples of simplifying radical expressions on this page, and then a couple on another page. The idea of simplifying radical expressions is kind of like the idea of simplifying fractions. So let's say I have this fraction, and it's a legitimate number, right? 10/15 is a number, but we have a simple form of that number. And we get that by dividing both these by a common factor, which is 5. And so 10 divided by 5 is 2, and 15 divided by 5 is 3. So we like to write the fractions in the simplest possible form. Likewise, we like to write radical expressions in simplest radical form. Okay, and so that's what we're going to do here. And there's a couple ideas that that we're going to use, and that is that, and I'll show you this here. One thing we can do in simplifying is, and I'll do this to show that this works for multiplication. If I do the square root of 0 times the square root of 0, I get 0 times 0, which is 0. If I multiply the 0 times the 0 first, I get 0, and the square root of that is 0. And if I did 5, so if I do square root of 5 separately times the square root of 5, we know that that's equal to 5. And if I do 5 times 5 first, I get 25, and the square root of 25 is also 5. So that works. Let's check this one. Square root of 9 times square root of 25. Square root of 9 is 3. Square root of 25 is 5. 3 times 5 is 15. if I do 9 times 25 first, I get the square root of 225. And I actually know that, but you might not believe me. So let's do it on here. Square root of 225 is 15, I believe. And there it is. And so we can see that that's 15. I'm not going to keep going here, but we're going to use this idea that you can split up numbers by their factors when you're doing square roots. Okay? And so for this problem right here, to simplify the square root of 28, what I'm going to do is look for perfect square factors, factors that I can change into whole numbers. So I'm just going to list all the factors of 28. 1, 2, 4, 7, and 28. I think I got them all. Oh, I forgot 14. 2 times 14 and 28. All right. Now what I'm going to look for are factors in there that are perfect squares. Perfect squares are numbers multiplied by themselves. 1 squared is 1. Don't use that one though, because that won't help us simplify. 2 squared equals 4. 3 squared equals 9. 4 squared equals 16. You might want to write these down because we're going to be looking for them all the time. 25. 6 squared equals 36. Go ahead and do 7, 8, 9, maybe up to 12, just so you have them there. So once I know that the perfect square factor 4, I'm going to rewrite the square root of 28 using that. So, and the idea that I just looked at here, the square root of 4 times the square root of 7, 4 times 7 is 28, right? Now, the reason I did that is because this number right here, I can write as 2. So I can have a whole number there. So the only irrational part of this number is the square root of 7. So that's my final answer. All right, you can do that with negative square roots also. You just have to list the factors of 50. And we can skip 1 because we're never going to use that as a factor. But 2 times 25, those are factors of 50. 5 and 10, those are factors, and I think that's all. And in here, the one of these that's a perfect square factor is 25. So I want to use that. I want to write that square root of 50 using that number. So 2 times 25 is 50, right? So I'm going to write this as negative square root of 25 times square root of 2. And that the reason I'm doing that is because I know the square root of 25 is that's a perfect square, so I can just write that as 5. So negative 5 times the square root of 2 is my final answer there. Any variable to an even power is a perfect square factor also, like this. And you might remember this from exponents. That's that number times itself, right? A to the 10th is a to the 5th times a to the 5th. So every even power is a perfect square factor. So the factors of 24 are 2, 3, 4, 12, 8. Let's see, 4 times 6, and 24 itself is a factor, and also a to the 4th and b to the 2nd are factors. Other a, like a to the 1st would be a factor, a to the 2nd, and so on. But we need the perfect squares from that. Now this is a perfect square here, 4, and both of these are perfect squares. A to the 4th equals a to the 2nd times a to the 2nd, b to the 2nd equals b times b. So we're going to rewrite this now, 24, a to the 4th, b to the 2nd, using our perfect squares. So we need to think of 24 as 4 times 6, because we want that perfect square out, times a to the 4th times b to the 2nd. Then we're going to separate those out. So we're going to do the square root of 4, times square root of 6, times square root of a to the 4th, times square root of b to the second. And that number we're going to write as 2. Square root of 6, we can't simplify that. It's not 3 times 3. 3 times 3 is 9. So I'm just going to leave that. This number we can write as a to the second. And square root of b to the second we can write as b. Now all of these have no square roots on them anymore. So I'm going to put this up here. So I'm going to write 2a squared b all together. And then the only radical I have left is the square root of 6. That's that one. All right, this video is about 10 minutes long, so I'm going to stop there, and I think I'll make this 2 parts. We'll call it 4.32a and 4.32b. All right, that's it. I'll check back with you in class and see how you're doing on this.